And welcome to SOL topic number 11B. This is on combinatorics. When we're talking combinatorics, we're really talking three things. First, the fundamental counting principle. If one decision can be made m number of ways and another decision can be made n number of ways, then the two decisions together can be made m times n ways. You take the number of ways each event can happen and multiply those together. A permutation. This is an arrangement of n objects when we're taking r at a time in a specific order. A permutation, the order matters. How you find this on the calculator? Well, let's pull up the calculator. We hit math, and then we go over to probability, and then we go down to number 2, the NPR. Combination. This is when we have an arrangement of n objects and we're taking r of them at a time in which the order is not important. A combination, the order does not matter. And we find that the same way. We hit math and then go over to probability, but it's choice number 3, the NCR. So we have two examples in this tutorial. Maria bought a new bicycle lock. She must pick a code that consists of 3 digits. No digit can be used more than once. How many different 3-digit codes are possible? Well, you might think of this in terms of the fundamental counting principle. So I see that there are 3 events happening. And these events are basically picking the digits. There, of course, are 10 digits, 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So she has 10 choices to pick the first digit. But it does say that no digit can be used more than once. So once she picks one of the digits, then she only has 9 digits for the second event. And once she picks the first 2, then there's only 8 choices for the third event. And if we multiply all of these together, we will have 720. And that is the answer choice. Think about it in terms of permutation versus combination. We're talking about a bicycle lock and a code for the bicycle lock. The code, of course, depends on the order of your digits. So order very much matters. This is definitely a permutation. So if we set it up as a permutation, we have 10 digits, and it's a permutation, and we're picking 3 of them at a time. So we can plug in 10p3 into the calculator, and we will also get 720. So I'm here on this page, I'll hit number 2. And we're looking for the first, which is the number of total objects that I have to pick from. And I'm going to pick 3 of them. So 10p3 is 720. Definite permutation. Second example, a box contains 8 tiles, each a different color. Sally is going to select 2 tiles without replacement. How many different groups of 2 differently colored tiles could Sally choose? So the question is this a permutation or is this a combination? Well, she's going to be picking 2 tiles out of this box, and I'm sure that the order of the tiles does not matter. If she picks out a red tile and then a blue tile, she has a group of 2 differently colored tiles. If she picks out the blue and then the red, she still has the same group. It does not matter the order. So this must be a combination. And if it's a combination, of course, we're going to be using that big C. We have 8 things to choose from, and we're choosing 2 of them at a time. So this is a combination of 8 things chosen 2 at a time. I'm going to pull up my calculator, and I'm going to hit math, go over to probability, and down to number 3. This time I'm choosing out of 8 things, 2 of them. So 8, choose 2, and we've got our answer 28. So you need to understand the difference between permutation and combination. When you're talking about codes, the order matters. When you're talking about just picking some tiles out of a random box, the order does not matter. And then the calculator will do the rest for you. Thanks for watching this tutorial, and hopefully you can do well on these practice problems in your packet.